Hello, everyone. In this lesson, I propose adding a feature for blocking ideas. So, accordingly, we will now have a user who has special rights to block ideas. This user will be able to block these ideas, and blocked ideas will not appear in the list of all ideas and cannot be accessed. Let's get started. There are fundamentally two different approaches. We can introduce a flag, something like an isAdmin boolean, and we will have a user or users with this flag, making them admins while others will not be. Based on whether they are an admin, we will check what is allowed and what is not. I don't really like this approach because it's one-sided. In projects, it's often the case that many people will administer it, and some have certain permissions while others do not, etc. Therefore, I adhere to the policy of creating an array of permissions instead of an admin flag. And the array of permissions will define all the rights a user has. This is a much more flexible system. At the same time, nothing prevents you from combining it with a flag, for example, by adding an additional role field. But somewhere in the code, based on the role, still, assign permissions for that role. But right now, I believe we don't need the role at all. It's just important to know what the user can and cannot do. And based on that, show or hide buttons, allow or deny the use of certain endpoints, etc. Then, permissions are some predefined ones. That is, we could just write string here and set some values, but it's inconvenient to work with. It's good when these possible strings are predefined. So, I suggest introducing an enum for user permissions. An enum is just a set of predefined strings. Roughly speaking, we've introduced user permissions, and accordingly, here our permission has become the following type. I suggest adding 2 permissions. We will have a block on ideas, meaning it can block ideas, and permission all. The one with permission all is like assigning all other permissions to them. This is very convenient because usually we create a preset user with all rights in advance, and whatever rights we add in the future, they will still have all of them. Good. That's concerning the user itself. And since we're implementing idea blocking, we need to add a corresponding field to the idea. Let's call it blockItAt, and it will be of type datetime. Accordingly, if blockItAt is not set, then the idea is regular. If blockIt is set, then it is blocked. Okay? Let's run our migrations. Crazy migrate dev. So let's name the migration. Add permissions to user and block it. Add to ID. Fine. We've sorted out the database. Then, since we need these rights visible on the front end, let's sort out our toClientMe function. I remind you, it is used in the getMe endpoint to get our current user, but in the format that is sufficient on the client. And in the endpoint, in update profile, when we update our user. Okay, and here we need to allow the person on the front end to see their permissions. Permissions. Right. Great. Let's move on. Next, I suggest adding an endpoint for blocking ideas. So, let's go. It's also in the folder. IDs block I. Let's run. First, define the input parameters. The input parameters are as primitive as possible. We will exclusively accept the idea ID that we want to block, okay? And let's create the endpoint itself, file index.ts, with the following content, all right? Well, so we have a procedure with input, mutation, Okay, idea ID is extracted from the input, and we haven't created this function yet, but we'll do it now, which checks if a person can block ideas. So, theoretically, it should work for us like this now. So, for example, ktx.me if I'm there. And permissions, for example, includes. So, like, it didn't pull. Let's restart the TypeScript service. So, includes. Block ID, well, it returns false anyway. So, for example, if not block ID, then permission denied. But at the same time, we might have a situation where it has all permissions. So, accordingly, we need to do it differently. Add another check to see if it has all rights. Right, but it's a very long string. I suggest moving it to a separate function. And generally, in this util.scan file, we'll store our other functions for permissions checks. For now, let's just trust that this function returns whether a person can do this or not. That is, if he cannot block ideas, then we throw a permission denied. Okay, then we need to find the idea itself. We look for it, ID. We look for it. If the idea is not found, we say I'd not found. And then you just need to update it. ID update. The idea with this ID. Set block.at to the current date. We return true because, well, we don't really need to return anything significant from here. We could return the idea itself with information about block date, but when we do the front, we'll see why it's not really necessary. All right. Okay, let's now get to implementing this function. In utils, we're adding a file, can.ts with the following content. All right, let's first go over the functions themselves. That is, we're creating an additional helper has permission, which we will use further in the canBlockIdeas function, which we are calling here. Has permission takes a user and a permission. A specific permission, which we import from Prisma client. In user permission, if you look, there we just have this simple string enumeration type in the object. All right? But nonetheless, this is a preset type, meaning we know it's specifically block ideas, or all. All right? What is maybe user? This means that it is either a user or not a user, because later on, here it was convenient for us not to check whether the user is authorized or not. We just checked if they can do it or not. But it's assumed that if a user is not authorized, they can do nothing. And if authorized, we need to rely on their permission state from the database. Okay? And accordingly, we do the following. If there is a user, we search for the specified permission in permissions. Suppose it exists, then the user can. Suppose it doesn't, or there is no user, we go here. If the user exists, we check if they might have rights to everything. That means permissions include the string all. In that case, what they can also do. If none of these conditions are met, then it's false. It means they can't do it. And accordingly, here's our function canBlockIdeas. It simply returns the result of the function has permission user block ideas. In the future, when you add more permissions, just do the following. Can_dead. Name it as you wish. And here you will also introduce new rules. It's very convenient to add functions for rights checking this way. All right, since we have a file for rights checking now, I propose moving checks here, like whether a user can edit an idea. Yes, this is not based on permissions, but it still determines whether a person can do something or not. So I think it's normal to store these in files named can.ts. CanEditIdea. I will probably pass the user and possibly the idea. We will need this in the future because the idea might not be in our endpoint. Let's say the idea equals null. So here's the check. There should be a user. If there's no user, then they can't. There must be an idea. If there's no idea, it can't be edited either. And if there's an idea, and if there's a user, their user ID must match the author's idea ID. That's it. This is CanEditIdea. We'll apply it later in places. We will apply it both on the back end and on the front end, and also allow importing functions from this file to the front. All right, so another. Once imported, good. The endpoint on the back end is ready. So let's now work with our other endpoints, which should rely on this module. But let's start with get ideas. Okay. Well, roughly speaking, if we didn't have any where clause specified here yet, I'll hide it for now, it would look like this. We need to find all ideas where the add block is set to null. By default, it equals null when it's not set. Because here in the database schema description, we said that this field is optional. If it's not set, it equals null. Yes, but we also have a thing related to input, and we need to optionally add this search only if input search is passed. For this, I suggest using the following construction. We say that now from these parentheses, we will return a certain object that needs to be integrated into this object, and it will be the next. If there's no search in the input, we return an empty object. Consequently, nothing will be added to this object, as it were. But if we do have input search, we will return our old object. You can check normalize search. Likewise, there's an extra curly brace here. And probably there's an extra curly brace here too. All right, yes, this kind of structure. All right, now our old functionality works as it did, but blocked ideas don't get here because we're only searching for those that aren't blocked. All right, we've sorted out endpoint.getIdeas. So now we need the endpoint.getIdea. Here we've got our idea, and I suggest we keep it simple. If the idea is found but it's blocked, we simply throw an error. The idea is blocked by the administrator. From a feature implementation standpoint, this might not be the best idea because even the administrator won't be able to review this idea later. But let's agree that if we're going to be smart about it, we should also make an unblocking feature and so on. And in this lesson, I mainly want to show you the principle of applying permissions. The feature itself is just illustrative. You can certainly make it much more complex and well thought out. And it would be good to do this in tandem with your designer to determine how it would be most convenient for everyone. For now, let's just make it so that no one can view blocked ideas. Okay, we've figured out the endpoint. All right, okay. Let's add the functionality to block ideas in our front end. So go to the idea viewing page. The plan is this. We have for users who can block ideas on each ideas page. There should be a button that allows you to block this idea. Let's add it. So let's import canblock.ids from the backend. Okay, it doesn't import it automatically. It happens. All right, let's import it manually. Insert it. Yes, check. We pulled this file from the backend, but it's giving us an error, and it's doing so because in our ESLint rules, we've defined that nothing but types and files should be imported from the backend. Input is not allowed. So we need to add an additional rule in ESLint. And here we'll just say that this file can also be imported. There, that's it. Now we are allowed to do this. Let's move on. So we checked if I can edit or block ideas. Here's this function. Just reminding you, we passed the user and checked if they have this permission. Next, we just have a div, a block ID. and the component with the block ideas button. So this button also needs to be added. So let's add it in this file. Let's do it here. Here's its code. Well, it accepts an idea ID. The idea type is a non-nullable idea returned from the endpoint to get idea. All right? Then we take our block idea mutation from the backend. Just one issue. We forgot to import it again into the index.ts file. Into the index.ts file, generate index. All right. So now it's here. Good. Here we have this mutation, and now we will need PC utility, and we use our hook useForm to create a form. Even though we have just a button without inputs, it's still convenient to use a form because our wrapper can handle errors, can show the button loading status, and that's why even a button without fields that sends something to the backend is often still a form. So useForm. Okay, here's the thing. So useForm, submit, validation schema, allowed to omit. All right. So we're not setting any initial values here. We're not setting any validation schemas here because there are no input parameters in the form itself. All input parameters for our mutations we can take directly from the idea passed to the block ID. Okay? And here, what do? We call our mutation to block the idea, and then in this same onSubmit, while continuing to spin the loading indicators on our buttons. We don't invalidate, but refetch getIdea. This function, once executed, only then will we consider onSubmit to be successfully executed. But this will work so that since refetch getIdea happens, we will immediately see an error that this idea is blocked, and it cannot be viewed. Okay, here's our form logic. And here, let's just import what we're missing. Form items reminds to simply add padding between our elements. Alert displays an error message. We do not have a success message declared here, so only an error message can appear. Hypothetically, it might happen. All right, our button. The only thing is, it's a dangerous button, so I want it to be red. And since I want it to be red, we need to add this color to the button. Previously, our button could only be green, and now it will be able to. So, good. Let's declare a type, which will be called button color. Why am I declaring it separately? Because I want to use it for both a regular button and a link button. Now we add this color directly to the types of props, which can be optional. And let's add it here as well. Color.buttonColor. Good. Then let's declare its default value here. Our default button color will be green. And we need to add the corresponding CSS property that will determine this color. Let's put it here. Good. So we will gather from CSS into a string color, hyphen, and the color passed here. It could be green, it could be red. Good. And the same needs to be added here, like this. Added. Excellent. The component is now ready for colors, but styles are missing. Let's add the styles. Okay, previously, these things were responsible for the styles. Now we remove background color from here and add the following, okay? We say that color green has such a background color, lighter on hover, even lighter on active. Here. Also, we have a variable red that we use everywhere, and I suggest using a set of functions in Sass for working with colors. Here you can manage some colors. That is, you can adjust our red, making it lighter by 10% on hover, and on active, making it lighter by 30%. It's similar to what we did manually when picking colors. Here we can automate it. However, in practice, this is not usually needed as your designer typically selects the colors and you just copy them from Figma. Still, you can do it this way too. All right, we set the button colors and return to our spot. That's it. Button is red. Great. And link button is complaining because I told it colors should be mandatory, but it should be optional. All right, let's see what's on the front end. Okay, let's go into the 15th idea. We get some error because maybe our backend crashed. Restarting and we see that everything is actually fine. Refreshing the page and our idea is just as it was. We don't see any block idea button because we don't have the necessary permissions. Our current user has an empty array in permissions right now. And what can we do? We can go to our database, find our user, and assign them the necessary permissions. But I suggest not doing it this way because when you deploy your project, you'll need to go into your production server manually. First, you need to create a user somehow, then assign rights to them. It's inconvenient. I believe that when initializing a project, it's a good idea to run some scripts to populate your database with initial content. What I always do is pre-create a user with the nickname admin, or some of my emails, for instance, and a password that I store in env variables. That way, I'm always sure that no matter what happens, no matter where I launch the project, I always have an admin user and access to it, which I set myself. So let's write a script now that will add a user with admin rights to our database. Here we go. The script is run in the backend, so we will create it in the backend. Hypothetically, it can be called separately from our code, so I would add such a thing to the scripts folder. And here we will create a file called preseatdb. Such things are often also called seed. Usually, seed means inserting some test data into the database, like a bunch of users and fake ideas, to see how they look on the front end or do something with them. This isn't exactly a seed, at least in this context, because we need it in production. So these aren't test users. This is really a pre-assignment for our admin. I often add a script in presetdb for inserting some configuration data into the database, like a config model in your schema with values important for the backend. Therefore, I believe that presetdb is not the same as seed, but the functionality is essentially the same. Okay, we will have this content. That is, it's just a function that takes our app context and calls the following Prisma command. Absurd. Here's a reminder of how absurd works. It looks for a record in the users table, searching for a user with the nickname admin. If it doesn't find it, it creates a user with the nickname admin and a password, and permissions all. If this admin user already exists, it will update them, making sure permissions are also set to all in case they were somehow reset. We now need an initial admin password defined in the file to be specified. I don't add it to the code so that none of the developers are aware of it. So we will store it in variables. Let's add it to the variables. Add initial admin password, just like this line is cut by at least one character. All right, don't forget to add it to both env_example and env. So, in env_example, we write 1234, and in our local env file, we can add the same simple password, 1234. All right? So, great. Now we need to call this function somewhere. Let's call it in our index file, right after creating the context. Oh wait, pre-ctdb cex. We also need to import it. Okay, saving. Excellent, backend is working. Accordingly, a user with the nickname admin was created. Good. Let's authorize under him now. Logging out from our previous user, enter admin 1234 here. All right, we're logged in as admin. Let's go to IDEA 15 and see our button. Let's see how it works. We press the IDEA block. Aha, excellent. We see a request for the IDEA block followed by a request for getIdea. This is exactly what we defined in our view IDEA page file. So, we first sent a request to the IDEA block and then refetched getIdea. Thanks to refetching getIdea, the data in our initial refetch has changed. An error occurred, and our view page wrapper displayed this error. Ops error IDEA is blocked by administrator. Great. This IDEA is not here. Now let's make sure it's also not in the list of all ideas. In the list of all ideas, the 15th idea has also disappeared. Let's block the 12th as well. Great. The 12th is gone. The only thing I don't like is that block idea has no padding. Let's play a little with CSS styles. Go to View Idea Style, and under Edit Pattern, add the idea block. Good. Indents appeared. Everything looks decent enough. What we did about idea blocking seems to be working, but I'll remind you that in the CNTS file, we also defined the canEditID function. Let's apply it everywhere we previously forced this kind of check to reduce the amount of code and make it more readable. So, where was it? There, where we used author ID, you can search for it. So, in this endpoint, let's use it here. If, no, canEditID. canEditID is not your ID. Okay, we used it here. So, on the back end, these are all the places where we had such a check. The remaining checks will be done on the front end. So let's start with the Edit Idea page. Here, when requesting an idea, we check if we can edit it to decide whether to show the Edit Idea form to the user. Currently, it looked like this, and we'll replace it with the following. canEditID, ktxme, and next, pass idea author ID. Yeah, we need to pass the idea itself, not the author ID. Great. So we integrated it here. Where else did we use this? We also used this on the idea view page to determine whether to show the edit button to the user. canEditID, we just passed me and the idea. So we need to import it too. Okay. So basically, we've implemented everything related to user permissions. The only thing I want to draw your attention to is this file. When I specified types, I didn't just use the user as a whole like this. And the idea is not random, because we originally take it from the Prisma client, and we use these functions on both back-end and front-end. And actually, on the front-end, this notation would be incorrect. So if you look here, now we get warnings, because the user front lacks some fields that exist in the back-end user. For example, there is no password. And for these functions, information about the password and some other fields is completely unnecessary. Therefore, I'm just showing here that the user is actually an object with fields like permissions and ID, similar to the user type in the Prisma client. So you can pass anything similar to this object, and it will be sufficient. In the concept, we only need to know the author ID because that's all that's used here. And thanks to this kind of structure, you can freely pass users and IDs here from either the backend or the front end. That's all for permissions. Thank you all. Let's move on.